Hello everyone, I'm going to do a quick demo of TDD, test-driven development with Java. There are so many examples on the internet, so this is one more example of adding two numbers, two integers to start with. We can add more features a bit later. Right, so I just have a simple project, Maven project. Uh, just had to add the dependency for JUnit. Do a quick clean install and ensure there's no test running there, and you have a clean build to start with. Apologies for the background noise. That's the way it is here in India. So let's start here. Oh, wait. Okay, let's start with a new test. My Java class called like my calculator. So I'm going to test. Okay. Actually, I just want this to be under a package. So let's do a new package under the new package com.balaji.com and move this. Okay, move this into that package. Yep, we factored that. It's good. Great. Let's do what before. You need to do this setup. Public void setup. Right. I'm going to have a calculator interface, which is now going to be shared with my calculator implementation as well. Calculator. Okay, let's do what's this? Alt enter, create interface, calculator. How would that want this to be under the source main directory? Not in test. Okay, that's done. Good. Now let's again one more time. Alt enter. Create class my calculator. And I want this to be under source main Java as well. That's all done. Fantastic. Good. Okay, let's run this test now. There's nothing to run, so it should just come back. Just mix the build in the background. So let's do a first test. That's correct. Enter. Okay. Void. Let's say add two positive numbers. Okay. Asset equals. Let's say add. Let's say okay. Before I do that, let's do comment for now. Won't accept your field. I'll just do control. Shift F. Okay. Refactor this extract to a field. Good. Asset equals calculator dot add. This pass two numbers, so this will now be 5. Okay, what's wrong with this? Static import asset equals, that's done. And you also do alt enter, create method interface. Yep, add call number 1, number 2. Good. Good. Now let's see if it compiles. Run the test. Okay. Alt enter. Implement the methods. Good. Rerun this again. That. Good. So let's go back and run that test. Right, great. Expected 5, but actual 0 because by default 0. So the quickest way to get this test pass by TD way is to make it 5. Great. So that worked, but that's a fake test because dummy implementation. So I have I have one more test where I'll just add 22 plus 45. That will be 67. Now if I run this test again, one of them will pass, one of them will fail. So now it's time to implement the test. Great. So let's go back to the implementation and do the real one, which is number 1 plus number 2. Okay, that passed. That's fantastic. Right. Now let's add some more tests. What if we add negative number? Add positive and negative numbers. So let's take an example of say minus 145. That'll be 55. So let's get a test. Check if it passes or fails. Should fail. Great. It's always good to see the test fail and then make it pass. So 955, the right answer. Run all the tests. Great, all the tests pass. Fantastic. Let's do one more. Do some refactoring by adding two big positive numbers. So for that, integer has max value, which is actually 21. You can see here 2147483647. So let's just do 2147 48 3647. I could have had this constant, but I don't know. Java might choose to change these values, or rather, look at the actual Java code. It actually has hexadecimal in there. So just have a decimal value now. If they choose to change it, I can come back and change it a bit later. So that's it. So that if I have my calculator app, I'm going to add this with that. So the value is 4294947294. So that whole won't vary because you can see it's too large for an integer. So now we can know that for this to work, it needs to be a long than an inch. Right. Now let's run the test. Okay. So I expected this, but it came back with something else weird. The reason being it's not able to box it. So if I now convert this to actually let's go back to test here. If I refactor this, sort of boxing again, refactor, change signature. Yes, change it. Return type could be long. Refactor that. Right. Let's see, it worked, or at least compiled after the first refactor. Okay, good. So it's been changed. So if I convert now, just box it to a long and a long, it should just work fine. That's it. It worked. So now we saw the test being failed, made it green, and then we had more test. We changed the logic to include two big numbers. So we factored that to have a long um, output to time. So let's do one more, this time with the negative numbers. Two big negative numbers. So that would be, if I go again to integer dot min value, it's -21743648. So it's this, this, okay, that'll be 36. So let's see it fail first. So -42946, but I want to see it fail and then see the next test pass. Good. Fail because of negativity. So right. So the implementation was very simple. We took two int variables and casted them to long and had a returning output should be a long type. And we had adding two positive numbers, two more positive numbers, a positive and negative number, two big positive numbers, and two big negative numbers. Those steps are enough to capture the logic here, but you can have some more tests if you want to add to just check if it adds with 0. Let's do one more with 0. Add with 0. This is where the testers really have a great impact, helping developers to write the code because they think about all the edge cases. So I can have 2 and 0. So that will be, okay, I want to say it fail first, always, as usual. Let's put some value. It should be 2, correct. So okay, I want to have one more test for the second parameter. Add 0 second 0 second number. I'll add one more 0 first number. So I'll now change this to 0, and that could be 400. Run this test. It should fail expecting 2, but actual value is 400. Correct. Run again. Good. Just to add two numbers, two ints. Yeah, I almost took like 2, 3, 4, 7 unit test. Shoot. That was a good one. Great. Thanks very much.